then. So, those who did recursion, how do you feel about it? How do you? Sorry, those who did a reverse linked list, how did you feel about that question? How do you feel about it? No
I
feeling.
think you can do it in a
Yeah, because
recursive way.
you're managing like 4 pointers, right? Like 3 pointers. You're managing the current pointer, right? You're managing the current. Okay, you're managing the current pointer. You're managing the previous pointer, right? You're managing the
Yeah.
next pointer,
The
right?
next
If you
point.
remember,
Yeah.
if you remember that question, right? You were like managing 3 pointers, right? And after we are done with recursion, you realize you can write a very beautiful recursive code to reverse linked list. So beautiful. So let's talk about recursion again. So recursion is this very beautiful technique that allows you to solve, a bigger problem, right? A big problem by breaking them down into sub problems, right? So you have a big problem to solve, then break it down into sub problems, right? And usually these sub problems are much easier to solve, right? So for instance, this analogy, which also is a recording, realize we ask you to paint, a bar, right? A rod or something, then like, paint just this whole thing feels tedious for you, right? They're like, 100,000 meters, that's so big, right? Instead, what you do is that you divide them into sub problems, right? Like you divide it into maybe a couple of pieces, and then after dividing them, you apply your painting skills, right? So like you paint this part first, and after you're done, then you paint this part, then you paint basically, right? You divide it and then you conquer. That's what we call divide and conquer. That's what recursion is. It allows you to solve a big problem by simply dividing it into sub problems, and then you apply some technique. Yeah, technique is the painting technique, right? To these sub problems. And by the time you realize you solve the whole problem. So again, recursion is for the lazy people who don't want to do things one at a go. So let's come to what, I'm going to jump over a couple of things because you're supposed to go through the materials and everything. So I'm going to focus on just, the very crucial parts, and then on we go. Okay. But even if you're new to it, please follow me so understand this. Okay. So that's what recursion does. First of all, you are going to solve a big problem by breaking it down into sub problems. So when we say sub problems simply means, you consider, so let's take like a list, right? A list. I'm going to start with a list first. So when we say subproblems, usually when we are considering things like we're considering what we call iterable data types or iterable objects. That is things you can actually go through them, right? Things you can divide into pieces. So for instance, if I have an integer, like if I give you the number 25, 25 is just 25, right? It's just a number 25. But if I give you a list, right? A list is an iterable, right? It's something you can look through, right? Something you can like divide it in different types of ways. So when we say big problems, we usually consider, operations on data types that can be, iterated through. An example is a list. So if I have a list, I can divide this list into various forms. I can have it one, the first entry against the rest of the entries. Please follow me carefully. We've entered recursion now, no, 2, 3, 4, 5, right? That is, a list. If I take a linked list, right? If I take a linked list, I can still divide a linked list. Do you agree? Does everybody agree? We can divide a linked list also. Like if I have the linked list 1, 2, 3. How can I divide it in one? One way I can divide this linked list. I can do the first node, right? That first node against the rest of the nodes. Do you agree? Please, are you following?
Yes.
Okay. If I take a tree, which you also look at today, which you're supposed to look at this week, if I take a tree, like node 1, node 2, like right, I can divide this tree, please follow me carefully, into this. I can divide this, I'm going to do something a bit tricky with this. I can divide it into node 1, node 2, and node 3, right? It's what I've done right now. This is one I can divide this tree, right? So given these type of data types, there are other ways we look at later, right? And you can divide them into smaller chunks, smaller pieces. Usually recursion is kind of a good technique to apply to them when I'm solving problems involving them. So lists can be divided. Usually I intentionally did it this way for a reason, because many of the implementations you see, we usually divide the list one against the rest. Linked lists usually see the division done one against the rest. Trees usually see the division done in this way. We first process the head node, then we divide it as the left subtree. This is called the left subtree, then the right subtree. Are we good to go? Are we good to go? Are we good to go? Okay,
Yeah.
good stuff. Next thing. Now we're going to first tackle the list, right? Apply recursion to list, and then we bubble down to linked list, then we bubble down to tree, see if there's time. So for list, right, we've already seen how we will apply recursion to list. Usually what we do is that we divide it the first node against the rest. So usually we call it, so let's call our list LST, right? So usually to apply recursion to this, what we do is that we have LST index 0, right? Then we have LST index 1 going, right? This one going is the same as the rest of the list, and this is simply, the first element. Now look at the next thing here. That usually gets people wrong, right? Gets people wrong. when you look at LST index 0, what is the type of LST index 0? If I have LST to be, and I think someone has even sent a code to the channel before, and they also had run into this issue. Now, what is LST index 0? Anybody? What is LST index 0?
It's 1.
It's an int, right? It's an int. Its type is 1, and this type is what? It's an int. What about list 1 going? What about this one? This is an int. What about this one? It's a list. Good. It's very good to know this. It's super good to know this. Okay, now let's move on. So we're going to now understand something called a base case and a recursive case. So put this thing in your mind. We'll come back to it later, but let it rest. Let it marinate in your mind. Now, base case and recursive case. Now, every recursive algorithm is broken down into these things. A recursive algorithm is broken down into these two things, a base case and a recursive case. The base case is usually the part where you don't think much, where you just handle things in a very fundamental way. And for a list, the base case is usually what we apply to that first piece you have here, that list index 0, right? That list, index 0. So as we said, the type of this is an int, so we're simply going to put this around it. Now, what's the type of this? What's the type of this now? After I put that square bracket around it, it's what?
List.
The list. Good stuff. So I simply mean a list of length 1. That's what I mean. A list of length 1, right? A list of length 1. That's going to be a base case for list. So we're going to apply the base case to list of length 1. And then the recursive case is length greater than 1, right? So when writing recursive algorithms involving lists, I'm just saying that we're going to apply a base case to every list of length 1 and a recursive case to every list. But when the length exceeds 1, we're not going to think about a recursive case. Does that make sense to everyone? Now, let's make it even a bit juicier. Sometimes the list you get is an empty list, right? Do you agree? Some of the questions they give you, they may say, oh, the list may be empty. We're going to add an empty list to this base case condition. And now we are done. Time to go into code. Does this make sense to everyone? Can we go into code now? Can we go? Can we go? Can we go? Can we go?
Yes.
Good to go? Good stuff. Okay. So now I'm going to take one question. Reverse a list. Let's make it even easier. Sum the list. So you're going to give a list like 1, 2, 3, 4. Everybody can do this with a loop. Now I want to do it recursively. So let's write our code here. Def, and please, you need these fundamental ones. You have to understand these fundamental ones, and then you understand, the bigger stuff, right? So let's write a function def sum, and we're going to pass LST to it. So first one we write is our base case, and writing a recursive algorithm base case. And what is our base case for list? Anybody? List of length 1 and the empty list, right? Let's do empty list first. So empty list. If somebody tell me the code. If LST is what? Tell me. I want somebody to speak code. Speak code.
If not,
Exactly. That's what I was waiting for. Exactly. So if not LST, right? It's the same as if LST is equals the empty list, right? Because we said that the empty list is a false value, if you remember. So if not LST, what do we do? So we want to find the sum. So this is something can as an interview. If the list is empty, logically, what should you return? Anyone? What do you return if the list is empty?
empty list.
You have to return, right? So what do you return?
0.
You return 0, right?
0.
Is the logical thing to return, right? Okay. Now, what about if the length of the list, we are still in our base case. So if the length of the list is 1, what do we do? Anyone? What do we do?
Return the value.
We return the value, right?
value
That's
in
first
the-
entry. Please, you have to say some more. Say some, whether you're not sure or not. Please say some, right? That's how we get there. Okay. Are we all good with this? So we have handled our base case and our recursive case. Are we all good? Are we all good? Are we all good?
Yes.
Let's go to recursive.
Why can't you not put this into okay, go
Into
on.
one what? Sorry, what?
I
so
was
what-
thinking of putting it into one line, but I just looked at the best case.
you can't do it in one line, right? Because they're returning different things, right?
Yeah.
Okay.
I just watched it. So.
Yeah.
Can I,
Yes,
before we
that is
move on,
so
why are
that
you returning 0, like the list of 0, like the index 0?
so we have to return list index 0 is like, so if the list has just one element, then its sum, it's simply the number itself, right? Like if I ask you to find the sum of the list containing the element 2, the answer is 2, right?
Okay.
Does that make sense to everyone? Okay, good stuff. Okay, now recursive case. Let's see how we're going to write the recursive case. This is my most beautiful part about recursion, writing the recursive case. It can be a bit tricky, I agree. But look at the recursive case. The recursive case, we're going to use another magic sauce we use, right? Which we've been preaching for 20 million years. Can anybody tell me what that is? If you've been following me carefully, you know I love this, seeing this so much. Anyone? Hey, I'm sad.
So
There's
we have to
something
split
I
the
actually say.
problem to a
I think,
sub-problem.
please, I know you apply to the left and then you apply to the
Yeah,
right,
but I didn't
but
say something. I tell you to do something to do something without thinking. I ate very good food yesterday, so I probably will miss that
you call
actually.
the function.
Yeah, but you do something. Yeah, you assume the function works, right? You
Yeah.
assume, right? Assume this is a secret source of recursion. Assume the function works. This thing, assume the function works. Like, oh, it's both. If it were somebody else, I'd have given them something, but it's both for so you can ignore. So it says you assume the function. This is the thing I've been preaching like 80 years now. When you're writing the recursive case, you assume the function works. What does that mean? Follow me carefully, especially if you're new. So what is the function you're writing here? Sum. Can we all see it? You're writing sum. Does everybody see it here? This is the function you're writing, right? Sum. Now, base case, everybody knows the base case. I need to write the base case now. Recursive case is like, it's a bit difficult. So what we're going to do is that we're going to assume the function works. What is that function? The function sum. Now, we assume the function works, number one. Then number two, you call the function on. For here, we're just going to call it on, let's call it on the left. On the left and right. Let's call it on the right or on the sub-problem. Call it sub-problem. So what we are going to say is this. Look here. Please, everybody focus here. We already established how we do the division, right? We've already done the division here. Like we can do it one. I think we wrote it somewhere here. One, right? This first entry against the rest of the entries, right? That's what we're doing here. Like take the 0th item, then the rest of the item, right? Then number two, we're going to assume the function works. When the function works, what we mean is that you've been asked to write the function sum to find the the sum of all numbers in this list. But then if I assume the function works, that means that if I call sum on 2, 3, 4, I'm assuming that it gives me the answer of what? Somebody. 2 plus 3 plus 4.
9.
9. Thank you. 9, right? So this is what we're going to do. We're going to, please follow me carefully. We're almost there. So we're going to have left, right. So left is simply going to be the first. We're doing the division. That division we have here. Just doing that division we have here. Left, let's just make it list index 0. That integer. Then right is just going to be the rest of the list, right? Follow me carefully. Follow me carefully. If I assume the function works, that means that if I call sum on right, let's call it right value. What would that give me? What would that give me? What would that give me? Assume the function works. So if you call sum on right, what do you get? Somebody help me. It gives you 9, right? Please follow me carefully. Once you understand this, you have done like almost with recursion. Okay, it gives you 9. Okay, now what is the type of list index 0? What's the type of list index 0? What's it? It's int. So, but if you put the square bracket around it, it becomes what? A list. That's what we did here, right? There's nothing we have done, right? Okay. So now that means that let's also do left val. If I call sum on left, what am I guaranteed to get?
The number.
Right? Let's use this same example. 1, 2, 3, 4. What does it give me?
1.
1, assuming the function, right? Now, if you solve this question, what should be your answer? Sum of 1, 2, 3, 4, 5.
Give you 10.
10, right? So can I confidently write return right val plus left val? Do you agree with this?
Yes.
Yeah.
Yes.
And lo and behold, that's the whole solution. We've literally solved this question. And that's the whole solution. Like, it just works. And that's the magic. And this is the crux of it. But I want people to look at this code first before we talk a bit more. That for some people, maybe since I wrote left first, they want left to come first. Don't worry, I'll bring left first for you. I'll call someone left. What am I doing? Let me move this guy down. So those who have some interesting compulsion, and people will be like, let's bring left first again. Don't worry, I'll do everything for you. Left val plus right val. And lo and behold, this is the whole solution. This is the solution. Take your time, look at this before I talk more. Are you not looking? Some of you have seen this like 20 million times. Can we continue?
Cornelius, I have a question.
Yeah, go for it.
So instead of with the left and the right, could you just sum up in the returns function, like so that instead of writing all the 4 lines, it would just be a single line?
Oh, yeah. I'm essentially breaking it down like this. So you can actually just do left is equal to sum list index 0. But look, somebody will even know that. What is sum list index 0? What will it give you? What is sum list index 0? When you call sum on list, if you call sum on a one item element, what will it give you? Please follow me. What will it give you?
The value itself.
To give the value itself, right? So you can literally just simplify this. Like you don't even need to call the function on left. You can just pick out that number. Like you can just pick out like that's list index 0. The one that I say just makes sense to someone.
Yeah.
Like so it saves you time. We don't make that recursive call. But I just wrote a very fundamental algorithm, which we refine with time. But does this make sense to everyone? This algorithm makes sense to everyone. Like I want this code to make sense to you. Like don't think extra things. Just try to understand what is in front of you now. Does it make sense to everyone?
Yeah.
Okay, can we step it a bit higher?
It's Cornelius. I
Yeah.
want to see a situation where the base case will work. Like base case. I want to see it.
Oh yeah. So if I ask you to do sum of 1, it will hit the base case, right?
Just
If I have sum of 1, right? What's the length of this one? Is 1, right? So then it will hit this part, right? Then it will return 1, right? So we will only come down here if the length is more than 1, right? If the length is more than 1, divide the list into 2. Let the first number be its own list. Let the rest of the list be right. Call your function on the first part, call it on the second part, and add them. Because we're doing a sum, so the logical thing to do is to add. Anyone else? Yeah, you might go on. Yeah. Are we good to go? Now, let's step it up a bit. Using the same function. Okay. Now we can all see that. Look, we can all see that we did our division 1 against the first element against everything else. Can we all see that here? Can we all see that here? Can we all see that it was like the first one against the rest? Can we all see that here?
Yeah.
Okay. Now, we can also do it middle. We can literally slice it through the middle. And we can write the same function, and it works. It doesn't matter what you do the division. You can do it everything except the last number. You can do it anyway, anyhow. But simplicity helps, right? That's why we just do the first element against the middle. So that's one thing I wanted to say. It's not like just do it. No, if we could literally, look, we could actually make our lives harder by doing the recursive case. Let's find the middle. That is going to be length of list divided by 2. And you see this when you write merge sort algorithm. This is basically the merge sort algorithm. Divide it to 2. Then here, left is going to be list of everything up to middle. Then right is list of everything from middle going. Then everything else becomes the same, right? Call left, call and right, and do this. It's the same thing. Does that make sense to everyone? Like you can do the division everywhere. It's divide and conquer, right? You can divide 0 against everything. You can also divide right across the middle and it will work. That makes sense to everyone. So what I want to drill through this second part is this: assume the function works. By assuming that our function works, right? We just believe that if I call the function on the left, it's going to give me the right answer. I call it on the right, it's give me the right answer. Then the next important thing, that is number 3, which I'm going to say instead of writing here, is now I have the left answer. I have the right answer. How do I combine them? This is the crux of the thing. So there are 3 parts of writing a recursive algorithm. In my experience, number 1, write a very good base case. If the base case is wrong, this will be wrong. Like the whole function will be wrong if the base case is wrong. Because you realize that the base case, the correctness of this recursive case is going to rely on the base case, right? If it calls left, if left has one element, it's going to end up hitting this guy, right? This base case here. So if this base case is wrong, can you see that the left value will be wrong? Can everybody see it here? So always spend time, make sure your base case is right. After your base case is right and you think you have done justice to the base case, come to this recursive case. There are only 2 things you need to remember for your recursive case. I'll tell you. 1, you divide it and then you call the function on the respective parts, assuming that the function works. That is number 1. Number 2, the combination step. How do you combine it? Once you assume that the function works and you make the recursive calls, ask yourself, what will they return? And after you have seen the return values, ask yourself, how do I combine them? That is the third thing. How do I combine them? Here, because it's just a sum function, we know that Combining left val and right val gives us the right answer. Comprenez-vous?
Oui.
Good. Are we all good? Now, next one. I want everybody to try this and send their solutions to the chat. Let's write a function to reverse a list. Actually, yeah, let's do reverse a list. Anybody, try it. Reverse a list. Write a recursive function to reverse a list. Def reverse. I'm giving everybody one. Literally can use 2 minutes. 2 minutes for this. Let's reverse a list. You pass LST to it and reverse it. I'll give you pointers. Write your base case first. Everybody try and type something. Put in the chat, yeah, like try something. I want to see people's solution. Please, everybody try. Like, hey, somebody is done already. Who is that? Abel. Okay, good stuff, right? Abel is done. Okay. Someone reverse a list. Please don't copy somebody's solution. Try yourself, right? Reverse a list. Using the logic we used here. Let me still show you. Using what we had here. Try to reverse a list. Somebody try. Somebody try it. I'm going to add some formatting to the very important parts. So the combination step is important. How you do the division is important, and you have to assume the function works and follow the function. Oh, just have one. Please try reverse list. Everybody should try. I only see at least 40 submissions. Like, try. Or should we break it down? Okay, base cases first. Base cases. Everybody send base case. Everybody send base case for reverse list. Base case. We already did base case for list. What's the base case for list? The empty list or a list of length 1. So I'll be a base case. Everybody, I want to see everybody's base case in the chat, I beg. Base case for reverse list. We already discussed that for list, the base case is the empty list or list of length 1. So if I ask you to reverse the empty list or list of length 1, what will be the answer? Anybody? I want solutions in chat. Not linked list. I mean like regular list, like array list. Okay. I like the base case I'm seeing, right? So the base case is, if it's the empty list, what do? Return the list itself. Do you agree? And if the list has length 1, 2, what do? Just return it. If you reverse a list of length 1, it's the same list. Do you agree with that, with those base cases? Everybody, do you agree? So I'll write that here. So imagine this is one of the places where you can combine the cases. So if I'll just be like, if length of list is less than 2, return list. Does everybody agree with this code? Do you agree? Does everybody agree?
Yeah.
Please, for list, I always advise that for list, please do your base cases 2 things. A list of length 1 and the empty list. I see the reasons. You can see the solution John has sent right now. It can lead, I'll show you later, but I advise that the base case for list, consider the list of length 0 and of length 1. And you know this, the code we have here does justice, right? Do you agree? Please, does everybody understand this?
Yes.
Okay, now let's divide our list. We're going to divide our list into 2. We're going to call it the left part, but we can call it first and second, right? Let's just use left and right. Left and right. How should we divide our list now? Let's do it 1 against the rest. Everybody agrees? 1 against the rest. Are we good? 1 against the rest. Anybody not in support of this motion? Okay, simplicity pays, trust me. 1 against the rest. So let's say the left is simply going to be the list of length, the first item, right? Let's make it a list for now. Right is going to be the rest. Do you agree? Do you agree?
Yeah.
Okay, let's move on. Then left value. The value for the left, if we evaluate it, is simply by calling reverse on left. Right value is by calling reverse on right. So now, if we have this example, 2, 3, 5, somebody, what will left value be? Somebody help me. 2, 3, 5. Okay, let's start. What is left in 2, 3, 5? What is left? 2, 3, 5. What is left? Put in chat. Speak. What is left? 2, right? It's at least 2. Look, we put this one around it, so it's at least 2, right? Okay. Now, what is right? What is right?
It's 3, 5.
3, 5.
It's 3, 5, right? Okay. So then, if I reverse left, what do I get? See, your base case is literally giving you the answer.
2.
I get the list
2.
right. Look at this part. If I reverse right, what do I get? What do I get?
5,
5-3.
5. Yeah.
Now,
Wait,
the next
wait, I want
important
to
part.
understand this part. This part, how is it 5-3?
Because you are assuming the function works. Now, this question you might ask is why always when you get an interview in a question, the interviewer comes with examples, right? For every interview question you get, they come with examples. Then they give you the inputs and then the outputs. You just have to ask the interviewer, given this input A, what is the output? So if I ask you to reverse 3-5, you ask the interviewer, what should the output be? The interviewer will be like 5-3. Does that make sense? Because that's what the reverse function is doing. The reverse function, the output here is based on the definition of the reverse function. The reverse function says that if I give you a list 3-5, the output should be 5-3. And you're assuming that your function works, meaning that if I call reverse on 3-5, the answer should be 5-3. That is why in every interview, you have to make sure you understand the question, understand the examples the interviewer brings, input, output. See, till you understand the question and examples, don't write code. Don't even try to give any algorithm. Always understand the question. Because if you understand the question, then if I ask you what is reverse on 3-5, you can confidently tell me that it is 5-3. Do we all understand?
See.
It's very important. I know people who get questions, they start solving code. No, always understand the question and the examples first. Because if you don't understand, what are you even doing in the first place, right? Okay, let's proceed. So now the question then comes: if you indeed understand the function you are returning, right? What should the answer be? What should be the return value for 2-3-5 if you reverse?
5-3-2.
5-3.
3-2.
Do we all agree?
Yeah.
So given left val and right val, how can I get 5-3-2? Somebody help me. Somebody help me. That's a combination step. I'll call it results. What is it? How can I take
right
how can
val
I
and left val?
how can I take left val and right val and get this output I need? Somebody help me.
You can add it.
How do I
Right val plus
some people had their
plus
solution. Exactly. Some people had their solution. They had written left val plus right val, but that is
Plus right val.
can you
Yeah.
see why this is wrong?
Because that's going to give you
they
like
add
2,
the
5,
into
3.
Yes, because that'll bring the 2 forward, right? And then you'll be wrong. So the combination step is very important. So this is wrong. It has to be, as they said, right val, so that this one will come first, right? Plus left val. And we are done with the question. This is literally the whole solution. To reverse a list using recursion. We are done. Of course, you can make it feel this can be like 2 lines of code if I write this code. But we just break it down so everybody it makes sense to everyone, right? So this is basically the whole solution. This is the solution. Do we all understand? And this recursion is literally recursion. Because what will happen is this: at the end, when we do the coding demo, you see it that this thing we have here is recursive, right? We are calling the function, we are defining this function, but we are calling it again. That's why we call recursion. It's like solve me. Then I'm like, in solving you, I need you again. In solving you, I need you again. Then it becomes like this. But it will not continue forever because of this our base case. If not for this base case, they'll keep on calling each other, like those of you who, when you were in high school or JHS, you got a boyfriend and girlfriend, you'll be calling each other, like sleep, oh, don't sleep, oh, you sleep, oh, you say bye, no, you don't say bye, you say bye, and so on and so forth. I'm not saying because I have experience, but so on and so
So I
forth.
have a question.
So yeah, so that's how recursion works.
I have a question, Cornelius.
Yeah, go for it.
So in this right goes to first one to the sin, which give me 3 out of 5. If I now call the reverse function to give me the opposite 5-3, the way you're trying to tell me.
Yeah, if you assuming the function that's the superpower of this. That's the secret sauce of this. This thing, assuming that the function works, right? Which means that, right? If you call that function reverse, right? If you call that reverse guy, right, on right, you are guaranteed that it will give you the right answer. It's a big assumption to make, but it works, right? And if you read the textbook we asked you to read, it's obviously what is a girlfriend. If you read a textbook we asked you to read, that is what Jay also says. And I learned that thing from Jay's book, and it just made my life of recursion so easy. See, there's something I've been saying here, right? And those of you who have been listening to me, that you have to cherish knowledge. You come across something like this, like you have to be like, they said it works. Like you have to value it, you have to cherish it. Don't treat this as another side thing. No, like this thing, it works. Like I've been using it when we get to tree. You realize many of the tree are going to be right. And even all the, like, I'll be just using this assumption. I would just be assuming the function works. So if you don't cherish this thing and understood this thing, you'll be thinking, like, you even understand what we are doing here. So I beg you, after we're done with this, go and sit down underneath the sun or in the darkness or wherever. Just cross your legs and just be like, assuming the function, and say it to yourself 20 million times. Make it sink in. Or 273 times, anyone which works for you. Make it sink in. Assume that function works. It'll make your life much, much easier. Okay, can we step up our game? You are supposed to visualize recursive algorithms and see how it makes your life easier and everything. That's something you're supposed to do. Maybe if I show some messy, we see it at the start. But I wanted to jump to trees, sake of time. Because our schedule is by end of July, by mid to end of July, we're going to be done with all the high yield data structures and algorithms questions. And in July, we're going to do a lot of problems. We're going to solve a lot of questions to apply all the things we have learned. So if you just joined, please increase your pace. Are we good to go?
Yeah.
Okay. Also to Omar, what is a girlfriend? A girlfriend is a girl who is more than a friend. I think that's the best solution to that. Okay. So now trees. Okay. So let's end the recording now and let's. Actually, wait, don't end it. Don't. Before we go to trees, let's do the recursion. Let's do the recursion code demo, right? I just want people to see the stack visualized. Does that sound good? So to make things more clear to people too. Okay, so let's do a code that. Oh, okay. I'm trying to, okay. Okay. Let me share screen on this and I want us to see the code. The code. Okay, can everybody see my screen? Can everyone see my screen? Okay, let's go on. Okay, let's go on. So CS tutor. Let's just do the reverse thing we did. Dev reverse. What are we doing? Let's reverse. We take a list. LST. I think I said this probably in coding room. Like if you're writing your own code, right? There are things you call keywords in a programming language. For instance, the word list already exists in Python, right? The word max already exists. But again, men, like range, right? Like salt, they exist. So when writing your own code and naming your variables, don't use these keywords. If you look carefully, right, even when you use them, the color changes. Like this is less black. Like if you do it in lead code, you see the same thing. Like if you're naming your variables and those things, don't use the keywords because they may confuse you. Somebody who doesn't know who reads your code later may also be confused, right? So make sure your naming is good, right? That's why I'm using LST instead of list, right? Like because list is a data type in Python, it's a keyword in Python, right? So don't use keywords if you're writing your own variables. It's not healthy, it's not hygienic. It makes it feel sick, So list. So we want to reverse base case. Always base case. I said list base case. I highly advise use list of length 0 and length 1 unless you have a reason not to. So if let's break everything down. If list is equal to the empty list, if I reverse you, I get what the empty list. This one you don't have to think, right? You are there. If right, somebody be like, let's do elif, but I just do if because if every time we need if is because if this is executed, it's not even come to line 9, right? So if length of list is equal to 1, right? Then what do? I return that list, right? If you can also do if length of list is equal to 0, it's the same thing. There's so many ways to kill the same cat. God bless programmers. But that means God bless us. Okay, now recursive case. So it's a recursive case. The length, right, is more than what? It's more than 1, right? So we said do 2 things. Break it into left and right. So left is going to be our list. First, we take the first item, right? But we said this is going to be like an int or a string or something, right? We put the square brackets around it. Also, you can also just do this. You can also do, if you want to do slicing, you can just do list up to 1, right? Not including 1. Up to but not including 1. This will also give you the list, right? Then right will be like this, right? So this will be like the first, and list containing like the first item. So like this, and this would be something like, we are going to use 3, 5, 7. So this would be like 3, and this would be like 5, 7, right? Then we said, let's call the function on the left and right halves. So go and call that left value will be reverse left. So we're going to assume the function works, which means that if I call reverse on left, and look, you can see it. If I call reverse on left, just like saying reverse on 3, right? And can you see it to hit the base case on line 9? Can we all see it? Because the length is 1, right? Can we all see it? Like I'm not wearing glasses, but I can see it. So like how much more everyone? Can all see it? Okay, so that returns 3, right? Because of here's the base case. Then right val It's also like reverse on right, right? And that also is the same as right. Call reverse on 5 and 7. What would that give you? You're assuming your function works. Assume the function works. So what would that give you?
I'll give you 7 and 5.
7 and 5, right? I hope you all agree. Then, so give with 3, but then let's see, what should our answer be? When we reverse the whole thing, what should our answer be? Like if I call reverse on 3, 5, what should the answer be?
7, 5, 3.
Good. Mr. Kabio, or put it in chat. It will help you, it help you also focus. Those have short attention span. This is how you get yourself engrossed. So what should the results be? What should be the combination step? What should the combination step be? Should it be what should be? It's a very simple combination step here, right? What should it be? Anyone?
Right vowel plus left
Right.
vowel.
Right vowel plus left vowel. And you can just return the result, right? Ta-da, we're done. Now, let's visualize this. This is the cool part I wanted to show you. Let's see how somebody will be like, how does this even work? When I was like 87 years old, I used to wonder to how does this even work, right? Then I came to this. So let's do that here. Let's call this function reverse. Let's see how this function is going to work. 3, 5, 7. Everybody focus here. Like, okay, now you're going to visualize. So let's see how it's going to evolve. So let's start from here. So we know what does red arrow mean? I've said this thing like forever. What does red arrow mean? Anyone?
Code that's about
Is
to
it mean here?
execute.
The next line to be executed.
Yeah, it's next to execute. What does green mean? I'm helping you.
It's executed.
Just executed, right? Okay.
Yeah.
So here we've called the reverse function, right? We've called reverse, as you can see. So this was what happened. It was a function call. It just executed this function call. Reverse 357. Then it comes here, first checks. So would it be true or false? What will happen? I want you to tell me what will happen before I hit next. What will happen here? On line 6. This thing is so important too. This is what we call debugging. Like you have to know what the line of code is doing, right? Because you get stuck in code and like you'll be like, what is happening? So what will happen here on line 6? True or false? Because this is list. ID 2 is 357. So what will happen? I want everybody to say something. Put in chat, like,
False.
do plain language.
False.
Let's do something. Okay, false. Good stuff. So we come to line 9, right? What will happen on line 9? When you tell me false, just tell me the line we are going to. By
That
the
one's so
way,
So we'll go to
this
9,
also
13.
this also false, right? Because
Yeah.
the line is greater than 1. Okay, then we come here. Comments will be ignored. Line 13, right? So what will be the value of left? Somebody tell me, what will be the value of left? Tell me. What will left be?
3.
Oh, there's even a
List
pause
of
there.
3.
A list of 3. So as you can see, left is a list, and it's a list containing only 3. We cannot see it here, right? Can you also click on this right part to see the thing changing? Then we go to right. What right also be? I already told you. You're welcome. Okay. So now look at the thing here. We're not come to do our first recursive call. Look, we have just so now you call a function. A call frame is created for the function called reverse, right? As you can see, frames. So can you see we have only one reverse? We have only one square, one box for reverse here, and that is from the first one, right? That is from this on line 23, right? But you see, it's come to call reverse again on line 16, which means it will call the function itself and a new frame will be created. Does that make sense? That's what you call recursive call. You call the function again. So this function, this box you see here, this blue box you see here, will call another one. So it's like, now it looks like call reverse on 3. The big problem you were supposed to solve was call reverse on 357. But you broke it down into sub-problem. You're like, well, that's the first part. Let me call reverse on 3. And then it begins to execute the code from scratch again, anew. So now what will happen on line 6? So you see, we first went through this again. But that time it was for this box up here. It was for this one. But now we're going through it again for this second box. That's what we call recursive call, right? So what will happen on line 6? Anyone?
I want one,
True or
so we'll
false?
go to line 9.
Good. We go to line 9, right?
Yeah.
And then what will happen on line 9? True or false?
True.
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 Yes.
So to tell you that, so now it comes to line 10 to return it. So look at something here. What is the return value?
3.
3.
Is that list, right? Is that list that is containing 3? Look at something that's coming to happen here. Look at what will happen here. Everybody pay attention. So it's going to return this guy, right? Look, this is a return value, right? Now, when did we call this function? That's something that I want people to tell me. When did we call this function? Where were we when we called this function?
We
On
were
left.
on left.
We were somewhere, right? It was line 16 of this first recursive call of this first reverse. Do you remember? Like this second
Yes.
call frame was triggered when we were on line 16 for the previous one. Like it may sound a bit murky, but that's what makes recursion fun, right? Like it's a bit challenging to your brain. But we all know that we call this current one when we were executing line 16 of this first one. Do you all remember that?
Yeah.
Yes.
So whatever this second guy returns is going to fix in here. That line 16 of the previous one. Comprenez-vous?
Oui.
Okay. This thing is easy to understand if you used to drink what we call leonio. I don't know what you people call it. People call it a handful malt. People call it, different things in Ghana. That's brownish thing. Those of you couldn't afford malt. Some of us could afford malt, but we just like this. So yeah.
Asana.
Asana, good. How did I jump? Good. Asana, right? Sorry, I overjumped. Let's come back a bit. I beg you. Okay. Today be today. Okay, let me go. Yeah, Asana. If you used to drink Asana, this is very easy to comprehend. Okay, so left is this. I am so sorry. Wait, I want to go back. I want to go up. I stepped up a bit too much. Okay, so we're here. So right when we return this reverse value, it's going to fix in to that line 16, right? So look, follow me. Can you see the current state? When I hit forward, can you see now left val has a value here? And you can see this ID3. Look, it was that same return value is ID3, right? And that's the same thing that is returned, and it's now fixed in place of that left val here. Can we all see it?
Mm.
And right when the function returns is done, Python will just eliminate it, just pop it off the call stack. So like go away, right? It'll just pop it away, just like a stack. Last in, first out. You were the most recent one, we pop you out, right? So now we are back to that same function, right? For the first guy, we are now going to line 17. It's line 16 triggered a whole different recursive call, but we are done. Now we come here. And to be the same thing, this is the tricky part. Look, follow here carefully. Here, we create another call frame, and we call reverse again. So you can see a new call frame has been created. What will happen? Line 6 is false, right? Line 92 is false. Do you agree?
Mhm.
Okay. Now we come to left again. What is left? ID5.
5.
Because now look, now we are splitting this. So is that splitting we did for this guy? Now we're going to do that same splitting again because it's still recursive. Because our recursive case is, hey, if you ever call this function and it's operating on a list greater than 2, split, right? Comes recursive case. So can we all see that happening again? Like we are further dividing that problem into more sub-problems, right? Because our teeth is still underdeveloped. We can't reverse 3 and 5 and 7 just at the go, right? Okay, so then we come. So what happens if we split 5, 7? What will left be? Left will just be 5, and what will right be? Somebody tell me.
7.
7. Okay, does it make sense to everyone? Then we want to reverse again, right? We want to call it on 5, right? So can you see a new call frame has been created? Yeah, that's a beauty of recursion. I'm not going to talk a lot. Just look at it. Be confused for a few seconds, then be impressed. That was a message I sent in the Slack channel. Then you do pop. So now this guy returns, right? Because if you call reverse on 5, it just returns 5, right? If you call reverse on also 7, it just returns 7. That also returns it like this. Now, so now we are here now. We are on the combination step for this guy. Combination step, left val plus right val. What did we say? Add them, right? What is ID 5? It's 5. What is ID 6? 7. In what order should we add them? Right val plus left val. And that is how it ends up reversing it to 7.5. So that's what happened. 7.5, we are there. But note, we got this, we triggered this call. When did we trigger this call frame? This current one. Where were we? We were
on line 17
of the first call frame, if you remember, right? So this ID 7.5 will come and replace this right val here. So if I hit next, you can see it's here. This 7.5 here. Now it goes to the combination step of the first call frame, and that adds everything together, and we are there, ID 8. And that's our answer. Ta-da! We are done. That was fun. Okay, are we good to proceed? Good to go. Okay, well, the 30 seconds,
I have a question.
Yeah, go for it.
Yeah, so I was out for a bit, like some minutes, and then for the first period, it was like for the base, it was length of
length of list
less than 2.
Yeah, it's the same thing, right?
Yeah, so it covers for this 2.
Yeah, it carries for these 2 cases, right? Because the length of the empty list is 0, right? The length of list one is 1, so it's like the same thing.
Okay.
There's so many ways to write the same thing, right?
Okay.
You can even make it more complicated. Can you write if length of list is greater than minus 100 and length of list, is less than 1 million and length of list, mod 2, mod 2 is equal to 0 and length of list is less than 2. Like this will also be the same thing. I hope you all agree. I hope you all agree. Please, we never wrote this, but yeah, it's the same thing. All this is gibberish. I'll just make it messing around. But yeah, it's the same thing. Okay. Makes sense? Somebody still thinking about the line I just wrote. It was nothing, I beg. Please, keep your understanding as it is. Don't confuse yourself. Okay. Are we good to go?
They're writing magic for us.
Yeah. Should we jump to what do you call it? Trees now. But look at this a bit, marinating it, like please understand these fundamental things. That is like, see, I told you people, I said this like I was like recursion, right? Practice problems, Python. Like when I learn recursion, like me, I'll go to a site like this, and then I'll sit down after getting some cold water to drink. Then just take this first. If you still have not got a solid grasp of recursion, take this guy. Like, like why did I have the solution here? I don't want this. I want to solve myself. Like they're like right, like just write it, like just they just want you to write what is happening here. Like Python, I don't want this solution, but like take this, right? And like write your solution. When you're done, hit submit. Like I'll do all these things. Like I'll do every one of them because it goes in increasing difficulty, right? Do sum. Try to do integers to string conversion in any base using recursion. Do this. Sum of nested list using recursion. It's now, making things a bit stronger, right? This is a very interesting question, actually. We can do this very quickly. Like now, we want to find the sum of all numbers in a list, right? But here's the thing. The list may also be nested. Let's do this so realize here, look at how we did the splitting. For a list, we just like one against all. Let's go to my last question on recursion. Let me go to, I really want to start trees today. I said we should solve the reverse linked list using recursion. Yes, at the end. It's a beautiful solution, reverse linked list. That's actually the solution I use now. Look, now I want to find the sum of all integers, all numbers in a list. But look at the thing. Now, our list may also contain lists. Today be today. Today be today. Can we all see this? So what will the answer be? I'll wait. Please do the math. We're not doing math competition, but what do you think the answer will be? 1 plus 2. Fast. 1 plus 2.
3.
3 plus 3.
It will be 3, 3.
Okay. So 3 plus 3 gives me 6, right? 6 plus 4. 10, right? 10 plus
10.
5.
15.
15 plus 6. 21. Some
21.
people's math skills were faster when they were in high school, trust me. After we finish high school, the brain has more things to think about. I can agree. Okay, so this is 21, right? So that's what I wanted to solve. So can you see that now we have list inside list and everything? But think about it. It's recursive. Like, and here's the thing. It's easier to solve these problems with recursion than for loops. Everything that can be done with recursion can be done with loops. But questions like this, where there's like, look at the strength of this question. This is actually the strength of this question. We can create a tree out of this thing. We can create a tree out of this question I have just given you. Not because there's nesting. Can you see there's a nesting here? Because look, the thing is at the top level, you have a list. So inside this list too, you have a list, right? Inside this list too, you have a list. It's like there's some level of nesting inside it, right? And when you have that kind of setup, recursion is usually good. It's really good. So look at how I write this, because I'm just going to write the solution. I'm just going to come up with the solution on the go, try to follow what I'm saying. I also explain it as I'm saying. Don't call it def sum. Let's call it sum nested. I'm going to have a list, the main list, right? Well, then I'll say like, if the length of my list, if my list is the empty list, I'm just going to return that list. I'm going to return 0. Sorry, I'm going to return 0. But then it gets a bit tricky. I'm like, I can't just, this is my base case. I'm like, for my recursive case, if the length of my list is equal to 1, well, I can't just return, this will no longer work, right? I can't just return this because that's first index. My list could have been something like this, right? It could have been something like this. The length of the list is indeed 1. Do we all agree? It's indeed 1, right? So I can't just do return list index 0 because the sum has to return an integer. Does that make sense to everyone? Does that make sense to everyone?
Yeah.
Good. So I'm like, if the length is 1, base case here is even a bit tricky. I'm like, no, I can still do something, some magic here. If it's 1, let me be like, if the type, right? If the type of, so let's get the value. Let's get that first index. Let's call it first. Let's get it here. list index 0, right? If that list index 0, right, if the type is an int, if it's an int, we're back to that same old case. Cool chop. I can just do return that value, right? Just return that value. Or list index 0, just return that value, right? If it is not, right? If it is not, I'm just going to be like return some nested list, some nested on first. So then I'll end up calling the function again, right? So then the function then becomes something like this. Some nested on. Now it's like I've opened it up, right? Like I've removed the outer parenthesis, right? And now I've got something like 1, 2, 3. Can we all see the beauty? Can we all see how pretty it is? Then here I just come like, well, I'll do my left and right again. Left, same thing, same old thing. Left is just what? List index 0, right? The list of list index 0, right? Then my right, I think people prefer people get scared when I do that. So just be like index 1 here. That's a list containing just the first element. Then right is just 1 going. What am I doing? What's happening? What's happening? Then I'm summing it, right? So I'm like, okay, if I have the value for the left, right, that's some nested of left, I can just add it to some nested of right. And I'm done. That's the whole solution. Well, we may be wrong, so let's try it. Print some nested. Let's try with the first one. Let's have a couple of cases here.
Yeah, Cornelius,
Yeah.
you wrote if type into brackets int, so
Oh,
yeah.
I'm so sorry. Thank you so much. If I had money, I'd probably get you a Mercedes Brabus. But
Thank you.
right, if it's an int, we can just return it, right? So let's print this and let's do it for different cases. So if you are a file like this, these are the cases you test on, right? Well, I can also test. What other case can we test? Anybody? What other case can we test? You can also just test a very simple case, right? Always make sure you wait for the simple case, right? Just contains 1, right? Do you agree? It should work for this. Do you agree it should work for this, right? Because the list may be nested, may also not be nested, right? Then we can have a combination, right? Where it's like some are nested and like, like, okay. Then today is today. Today is today. Okay, if length of list is 1, the first one gave us 1. Oh, there's an issue. Can we all see there's an issue here? There's an issue. Can somebody see there's an issue here? There's an issue. Can everybody see this one is not helping our cause? Okay, let me take one at a time. Can we see this case? Can we see that this is giving us a perfect solution? 1. Can we all see it here? That's a very easy case, but it's a base case, right? It just hits this one. And it came here. If type of first is int, return first. Can we all see that? That was the very easy case. Can everybody see it? Okay, now let's go to the case where we have this. So let's just focus on this guy. And what answer should we get? What answer should we get?
6.
6, right? Do you agree we should get 6? Okay. Execute code. It's giving us 1, 2, 3. But we said this is the whole code though. What's the issue? What is the issue? Sorry, that's 1 second. Sorry. What's the issue?
I'm taking it is the space. I don't know, I'm not sure.
What's the issue?
The space in
Look at the code. So that is like
you're returning LSP
on
in
line
the 0 on
13.
line 13.
on line 13. What has happened on line 13?
I think on line 17, we return like the sum of the.
Not necessarily. It's not necessarily on line 17. There's
13, you don't need to return this
line
one.
13. This guy, I did not comment out this guy, right?
Okay.
Because as I said, if the moment he sees a return, it will stop. It won't go to the rest. Do you see that in action now?
Yeah.
It will go on to the rest, but we don't need. We learned that this guy was problematic, right? So let's remove this guy. So now let's run our code again. Execute code. There it is, so pretty. 6, that's my school number, BV6. So pretty. Can we all see it? Then let's try the next case. Also, and pop, there we are, 15, and it's just pretty. Simple, right? The next I want you to touch on is that what is the input type of the function you're writing? It's a list. You don't see it's a list. Like the type of this guy is a list. Please, every time you call this function recursively, the input type has to be a list. It has to be a list. That is why Left, we made sure left is a list here. That is why we didn't do left of 0 here, right? Because if you do this, it's an int. You can't call the function on an int. You are breaking the constraint. It will give you an error. Python will give you an error, but C, C++, they all give you errors, right? So make sure that you pass in the right type, right? That's why here we're like, if it's a list, we only call it if it's on a list. Okay, does this question, sound good to everyone? It's a very beautiful solution, right? We just had to add this extra thing, but you see, it's the same algorithm. Left and right, assume the function works, call it combination step. You are there. Okay, can we go to trees now? I was able to cook this solution up like off my feet like that because like I was trying this practice, like come across something new, factorial, like what's factorial? You learn it again, like solve all these questions if you may. Solve it, ask for more, bask in them, Okay, are we good to go to trees? I really want to test trees today though, please. Can we go? Or we want to spend time and look at this solution.
Yes.
Okay, look at this solution a bit. Look at it, bask in it, look at it a bit. When you're done, say done. D for done. I'll put in the chat or something. I think somebody just said, I think Estama just sent me a message. It's like, good afternoon, my dear grandson. And I hope I hope by God's grace you're doing great. I was supposed to call, but I don't know where you are now and what you're doing. Please, can you lead in the Zion DEW tomorrow by God's grace between 5 to 6 a.m.? Kindly reply if you can. Don't worry. Yeah, okay. Yeah, it's a scammer trying to scam me. Okay, time and space complexity. We'll have to discuss that for recursion. It's very important. Now, before the time and space complexity, I have to teach something called tail recursion. And should we do that now? I want to keep that. How about we do that probably next week? I mean, like people have done a lot of recursion stuff and everything, but yeah. So the thing is that, okay, I'm just going to say something briefly, but I'll make time to really analyze this with you. But the thing is this. So you realize that when we were visualizing the recursive thing, right? Something was happening. We were adding call frames to the thing, right? Like every time we make a call, we're adding call frames. So every time we divide, we are pushing on call frames, pushing. Do you all remember? We're pushing that, right? And as you do that, that is taking space. That is taking space, and that makes
I'm
it
fine. How you doing?
right? But there's another case of recursion we call tail recursion. Tail recursion has constant space. What am I saying? Yeah, tail recursion. I usually use in functional languages like OCaml. See, let's do that like Golang, like the next recursive call, like time importance for recursive call. I don't want people to be here, but like, yeah. Okay, let's go to trees. Take off time. Are we good to go?